So we'll now talk about the iterator protocol in Python. We've seen part of this protocol, so a little part of it in the previous weeks. So we've seen the generator part of the protocol. So remember, generators were functions that used yield or list comprehensions, things like that. So the fact is that those generators, once they are created, they have a method called next. So you have an object, a class, an instance of a class, and this class has a next method. So those generators are specific examples of iterator, because an iterator is anything that has a next method. Now, an iterable is anything that can be used to create an iterator using the built-in iter. Okay, so if you want an iterable is something that has the potential to become an iterator, and a generator is an example of an iterator. An iterator is anything that has a next method. So examples of iterables are dicts or files, and when you use iter on a dict, you get an iterator over the keys. And a file is an iterable, and when you use iter over a file, you get an iterator over lines. So let's see how you can actually define your own iterators, and this is done here. So again, I have a to-do list, but a simpler example than before. So the constructor just creates a dictionary where every key is in the argument data here, and then the task is not done, so the value of that key would be false in that dictionary, and it uses the attribute tasks for that dictionary. Okay, so here is mark as done, which is a method that takes a key as an argument that will print that key is done and then change the value associated to that key to true to mark that the task is done. So for instance, here I would create a list, a to-do list, which would consist of go fishing, study math, and sleep. Okay, so and then I would like to be able to iterate over the list. So really what I would like, so at the moment I don't enter the iterable or iterator protocol yet, but as soon as I define iter, then I am inside the iterator protocol. So if I do iter self, I should return now an iterator. Okay, so because I've defined iter on to-do list is an iterable, and the result of calling iter on it should be that I return an iterator. So the iterator I'll return, well, first I could just do return iter task, which is what I did in the example last week, and this would return the iterator you can get to from self.tasks. Right? If I did just this, then this guy's a dictionary, so when I call iter on this dictionary, I would get an iterator over the keys. So in this case, over the tasks. Okay, so this is explained here. If I go from a dict, which is an iterable, and use iter, I get an iterator over the keys. But that's not exactly what I want. That's why I define my own behavior here, because I want to iterate over the tasks that are not done. And so this is possible in this way. So I'm iterating over the items in self.tasks. So this is task done. And then I'm deciding that I'm only returning those that are not done. Okay, so this defines, this whole thing here defines an iterator over all those tasks. So actually it does this using a generator, and here is another way to use a generator maybe more directly, and both of those ways are equivalent. So if I just run this here, python iterator.py, you'll see that I first define a series of tasks, study math, sleep, and go fishing. Then I mark go fishing as done, and then you see that the current tasks have changed. So this is how you define an iterator in Python. Remember, an iterator or an iterable in Python, an iterable needs to have an iter method that returns an iterator, and an iterator needs to implement next. So what's the point of iterables? Well, the point of iterables is that you can iterate over them. So you can have, for instance, 4 tasks in the list. And I don't need to do like mylist.tasks or something more specific, because here I'm not quite iterating over the task. I'm iterating over the tasks that are not done.